Alright, Calculus, we're going through some free response practice here, especially with the step-by-step packet. A few things to keep in mind. We're going to try and go through this process throughout the entire time here. We're looking for keywords, formatting or other details, given and implied information. What's the question, and then how do we answer that? If you just try to say, well, what's the answer, how do I answer that, but you don't have any context, it doesn't really back up or support your understanding very well. It's trying to memorize how to do 50 questions instead of trying to memorize how to use some problem-solving strategy. So this is kind of our strategy over here. This is the entire question, but we are going to take it one step at a time. In fact, for parts A, B, and C, we're going to do each of those separate. Some of them are tied together, but let's just start up here with just the prompt. So I'm going to fade these out a little bit. We're not going to focus on those quite yet. We're going to focus mostly up here on the prompt. Let's start with keywords. So what kind of keywords do we see in here? Well, there's not a ton of keywords, but what we could say, it's almost more of a formatting and miscellaneous detail. The idea that this is G prime, little f prime, and capital F prime. And also the idea that this is a piecewise function. Those are all important pieces of information that will help us work our way through that. Later on, we're going to go through those keywords that we see within the question. So the given information that we are given, f prime, and we're also given g prime, so we're going to be using those somehow. And we don't have any question or steps to answer yet, so let's go ahead and jump right into that. So part A here, it says keywords. Okay, find f of x. That is pretty much straightforward. It just says find f of x. That's our keywords there. But formatting and some miscellaneous details, notice that this here is f. It's not f prime, which means we're probably going to have to do something to get back to f, some type of antiderivative. So there's some formatting details that we're looking at. Given or implied information. So we're given this, f of 2 equals 4. Now there's some implication there. That means that when we plug in x equals 2, that f of x is going to equal 4. So let's start with the basics. What's the question? Well, it's asking us to find f of x. That is our question. Not too big a deal, but if we have f prime and we want to find f, what we want to keep in mind that means we have to do an antiderivative. So we're going to be looking at this as taking the antiderivative of f prime of x dx. And that's going to equal f of x plus some constant. And that constant of integration there, that's important because we don't have any interval here that we're integrating over, so we're going to have a constant, which that kind of brings back into account the given information. That's why they told us f of 2 equals 4, because that's going to help us solve for a constant. So we got to do two things here. We got to, one, take the antiderivative of 2, figure out what the constant is. So let's start putting our things in. If we were to take the antiderivative of f of x, keep in mind that on the previous page here was f of x, or f prime of x, pardon me. It's 30x squared over x cubed minus 3 quantity squared. So that's 30x squared over x cubed minus 3 quantity squared dx. No big deal, right? Take the antiderivative. Ooh, it looks a little challenging. So I want to show you some strategies that I see here. First of all, I see layers. I see a function here that's got an outside layer squared and an inside layer that has the, I can't even think right now, the x cubed minus 3 here. So layers to me implies that this is some kind of chain structure, which means I have to use a u-substitution. So if I'm going to be using a u-substitution, then I need to figure out what u is. Well, u is pretty much always that inside layer. Let's try that. That would mean u equals x cubed minus 3. Okay, well, let's make that substitution, see what happens. When I make the substitution, I'll have 30x squared, I got this dx, and it's over u squared because I take out the x cubed minus 3, and I replace it with a u. Now that's helpful, but I still have these other x's to get rid of, because when I'm doing a u substitution, the key thing is to replace all the one variable, in this case x, with u's. So I need something else that has dx in it, and maybe an x squared. Usually, not always, but usually the derivative of u, so du dx, is going to help us with that. So the derivative of this expression that we started with, this equation I guess, is going to be 3x squared. Now notice I just need to get rid of this x squared and this dx. So if I need to get rid of those, I'm going to do some algebra here. I'm going to multiply both sides by dx and divide both sides by 3. And then I would get du is equal to, or du over 3, or 1/3 du, is equal to x squared dx. So now that gives me two pieces to substitute here. I can substitute out the dx. I can also substitute the x squared. So that's going to be this piece here and here. Let's put a little box around them, make it nice and neat. So I'm talking about this piece and this piece. Excellent. So I'm going to take those out, and I'm going to replace them with du over 3. So let's do that. So we're at a new stage. That means that this is the same as 30 over u squared, and then we have a du also over 3. So now I got some simplifying I can do, and it's just a much simpler antiderivative. So the 30 and the 3, that's really going to become 10, and the u squared on the bottom becomes u to the negative 2 on the top. Now that I'm here, it's just a simple power rule. 10 is a constant, so I can factor it out, just have it tag along. It's going to be here. There's my 10. U to the negative 2, I add 1 to the power. I get u to the negative 1 over negative 1. Of course, plus c. Now we've done most of the work here, but this is really only half of what they were asking, even though it's most of the work. The other part that we had to do was solve for that constant. So let's get to where we can do that. U was x cubed minus 3, so I need to substitute that back in. We're going to have 10. This negative 1 I could multiply to the top. U to the negative 1 means it goes to the bottom, so that's going to be x cubed minus 3. And okay, so this equals that right there. So we have this plus c, and that equals our f of x. Okay, so once we're here, we just got to figure out what c is. So we got to plug in 2 and set that equal to 4, because x equals 2, f of x equals 4, means that we'll have 4 equals negative 10 over 2 cubed minus 3 plus c. Okay. Now I'm going to show you guys something. Because this is a free response question, you don't actually have to simplify. You could just say 4, and then if we move this other piece over to the left side, plus 10 over 2 cubed minus 3 equals c. Well, now I've labeled c here, and I've labeled c here. So I'm done. Excellent. I've said I found f of x. Here's my f of x. Oh, and by the way, here's my c that gets plugged into that, which the grader can do for you because you don't have to. So we got our answer. Excellent. Let's move on. We're going to do something very similar here. So first, let's look for some keywords and things as we go through this process. So keywords, continuous, that looks important. Notice some formatting here. With the formatting, we have a capital F of x, and this says g of x, but not g prime. So that almost implies that we're going to be doing the same thing. So the given information, what's given or implied? Okay, it's not obvious, but the idea of this continuous and f of x is continuous. So if we say that f of x is continuous, what does that mean? that means that at x equals 2 for a piecewise, because we are a piecewise function, that little f of x equals g of x. In other words, f of 2 equals g of 2. But wait, we know what f of 2 is. That's 4. So g of 2 also equals 4. So we're going to use that same thing, x equals 2, but now it's g of x equals 4. Because we're continuous, that means both sides have the same value at 2. Not everywhere else, but at 2 they do. So the question now and the work that we need to get there. So there's our question, and what is the question? Find g of x. It's going to be the same thing as before. How do we answer that? The antiderivative of g prime of x dx is going to give us g of x plus c. Okay, so we got g of x plus c. And as we're looking at that, we realize that's pretty much the same procedure, the same steps that we were looking at before. We're going to take that antiderivative, and then we're going to solve for c. Can't forget to solve for c. Okay, let's do it. Antiderivative, and this time we have x. It's on your papers, but I have it from the first question here. That second part, g prime of x, x cosine pi x squared, x cosine pi x squared, and dx. Again, I see layers, inside layer, and here's my outside layer. This extra x, now there's a little bit of advanced intuition here, but the idea that this is x to the first, and that's related to the derivative of the inside, is going to help me structure that chain from the inside. So what do I mean by that? Let's start with the inside layer. We got to do a u substitution just like before. U equals pi x squared. So let's make that substitution. We're going to have the integral of x cosine u dx. So I got to get rid of this x and this dx. Let's see if we can do that with the derivative. Du dx, based on this substitution, is going to be 2 pi x. Well, I could divide both sides by 2 pi and multiply both sides by dx. And that should give me what I need, but let's double check. So then we'd have du equals 1 over 2 pi du equals dx times x dx. So there's my two things that I'm going to substitute. It worked out just right, just like before. So I'm going to take this x and this dx out, and I'm going to replace it. So now, third stage of this integration, let's make these other substitutions. X and dx come out, but we're going to replace it with a constant, 1 over 2 pi, and the du out here. And we still have cosine of u. Okay, so now let's do an antiderivative. The antiderivative of cosine u, which is the only part of the function, this 1 over 2 pi is a constant, so you factor that out, then it just kind of tags along. The antiderivative of cosine of u is sine u. And then, of course, we have the plus c. And this is our g of x. We need to plug in u, which we have here, and solve for c. So let's figure out what we would get there. G of 2 equals 4, so that's going to help us solve some things here. We also know that u was pi x squared, so g of x is really 1 over 2 pi times sine of pi x squared, and we got the plus c. Okay, so now let's substitute some things in here. G of x is going to be 4, and we got the 1 over 2 pi, and then sine of, and we got pi x squared, which is pi, and then x squared. X is 2, so this is 2 squared, and plus c. Okay. So now, again, let's go through some of this. We're going to have 8 pi if we multiply both sides by 2 pi. Equals sine pi, 4 pi plus c. Well, that didn't really help us. We need to do some different subtraction there. I'm kind of doing some algebra errors. I can't multiply first to get rid of this. I got to move the whole term over. So let's start by doing that. So I got to subtract this whole thing. I got to subtract 1 over 2 pi sine 4 pi plus c. Now, something real quick, I don't know if this makes obvious sense to you, but sine of 4 pi is the same thing as sine of 0, and sine of 0 is 0. So this first term here, negative 1 over 2, or equals here, pardon me, 1 over 2 pi times sine of 4 pi, this whole thing equals 0. So that means that 4 equals c. There we go. So we've answered what does the constant equal, and right here, this is our final answer. And we don't actually have to plug it in because we already figured out what c is. Now here's something a little controversial. We just used a bunch of c's, but wait, we used them twice. We used c here in part A, and then we used it again in part B. So I shouldn't use c for these. Let's make these d's. D, 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 D. Then next you could do E if you want, or F, or you could say C1, C2, C3, but this constant is different from the other constant, and we need to differentiate those levels. If we were really anal about it and we wanted to write it out as is, we would have 1 over 2 pi times sine of u was pi x squared plus 4. There we go. All right, so part B, done. Let's see what we have for the next part, part C. So let's start looking at keywords again. Keywords for this, we got lots of them. So we got continuous, determine if capital F here is differentiable. It says show the analysis that leads to your conclusion. All right, so let's talk about some formatting or other miscellaneous details. Again, capital F, capital F. Those seem important. Then let's look at the given and implied information. So it's telling us that f of x is continuous at 2. Now we actually knew that from parts A and B, but if we didn't get those, if we didn't get that information, it's telling us, so that's implied. So we're continuous. That means that little f of x equals g of x. So what's the question then? The question is it differentiable? That's our question right there. So the question, how do we answer that? The steps to answer that question. So for something to be differentiable, for capital F to be differentiable, means that the derivatives would be equal, that the slopes from both sides would be equal at x equals 2. So even more specifically, f prime of 2 equals g prime of 2. This is easier than the other pieces, I believe, because we don't have to do any antiderivatives or derivatives. All you got to do is substitute 2. So let's figure what that is. F prime of 2. All right. That would be, if we substitute in here, we got 30 times 2 squared over 2 cubed minus 3. And let's see what g prime of 2 would be. G prime of 2 is going to be 2 times cosine pi times 2 squared. So let's do some simplifying here. We got a 2 and then cosine of 2 pi squared, that's going to be cosine of 4 pi, which is really the same thing as 0 or 2 pi, because if you're thinking about a unit circle or any circle in terms of radians, there's 0 to 2 pi, and then if we do it again, then we got 4 pi. So it's the same value for those, so that'd be 2 times 1. Cosine of 4 pi is just 1. Over here, we're looking at 30 times 2 squared. That would be 120. So that's 30 times 4. On the bottom, we have, oh, by the way, this was squared. Whoops, almost forgot that. 8, which 2 cubed is 8, minus 3 is 5, so that's 5 squared. Let's keep going. We got 120 over 25. That's not going to equal 2. What would this simplify to? It looks like we'd get something, an improper fraction or a decimal if you wanted to, But I know for sure 120 over 25 does not equal 2. Therefore, the limit as x approaches 2 from the left of capital F prime of x does not equal the limit as x approaches 2 from the right of capital F prime of x. What does this really mean? Little f prime of x does not equal g prime of x. So up here, this first statement, that's really technical. Down here, this is kind of the more abbreviated version of the reasoning. You need to have at least the abbreviated, but for full credit, you should really be thinking about trying to give the technical definitions for differentiability, which is the limit of the derivative does not equal the limit of the derivative from both sides. Or you could have just said the limit as x approaches 2 of capital F prime of x does not exist. That's the same thing when both sides don't equal. Okay, so those are the 3 answers. Remember, watch video more than once if you need to. This is video number 39. It's actually the first one I recorded for Step by Step, so hopefully you guys can use these to study for your free response Friday quiz.